Welcome to today's mini lecture. We're going to discuss in today's lecture the pH scale. We're also going to talk about what is pH and the pH of some common substances. And finally, we're going to look at the concentration difference between your hydrogen ions and your hydroxide ions. So let me go ahead and begin. First of all, if you look up here, it says pH equals. Well, what is pH? I get a lot of students who say it's the percent of hydrogen. And you're kind of, sort of, but not exactly. The pH actually is going to measure not the percent of hydrogen, but it's going to measure the concentration of the hydronium ions, which is hydrogen or protons that are free in a solution. Well, what does pH actually mean? pH is like X in math. It is a variable, or not a variable, but a constant, so it is a formula. pH is actually equal to the negative log of the concentration of those hydronium ions. So that is the definition of pH. pH is the negative log of the hydrogen ion concentration. So I wanted to bring this back up. You see where I put the little brackets? If it is a bracket, it means concentration. We just got through talking about making solutions, and we talked about the solute versus the solvent. Well, what we do for concentration is it's the number of moles. Definitely familiar with that, whether we're using the mole map or stoichiometry. However, the number of moles over the volume in liters. So it's a mole per liter. That is the concentration. So let's talk a little bit about the pH scale. The pH scale, pretty straightforward. It's set up so that it measures from 0 up to 14. So we have 7 being the divider. Anything below 7 is considered an acid. Anything above 7 is considered a base. If you are at 7, exactly 7, then the substance is said to be neutral. Sorry about that, guys. So the substance is said to be neutral at a pH of 7. Now, just go through and talk a little bit about what's going on. So if we're talking about the hydrogen ion concentration, the number of protons that are available in a solution, then the more you get, the lower the pH is, the more acidic it is. To give you a good example, we come somewhere over right in here, 1 to 2, that is going to be hydrochloric acid. Hydrochloric acid has a pH very, very low. It's usually going to be right around the 1, somewhere right in there. Give you another good example of a low pH is stomach acid. The acid that you have in your stomach is, you've probably been sick and it's real acidic and sour tasting. That's because it's very acidic. And it is a form of hydrochloric acid. So again, it's going to be down here close to that 1 or 2. Give you another example. This is one that people don't think of much. Sodas. Yeah, like a Pepsi or a Dr. Pepper or Mountain Dew, they're going to have pHs way down there because they use phosphoric acid and they use acetic acid and citric acid. All of these are used as preservatives in your different types of soda. So they're going to have a pH somewhere near about right around 3, 3.5. So come back up here to neutral. What's going to have a pH that's neutral? Well, of course, water, right? H2O, and then also blood. Right. Our blood has a pH that is very, very close to 7. It can be a little bit below, a little bit above, but not very much. Now we start going in the opposite direction. We look up here and lye, and I don't know if y'all have had any experiences with lye, but lye is NaOH, and it's going to have a pH between 13 and 14. It's one of the most basic of all substances. We also can skip down to about 10, and Somewhere right around 10 is going to be your cleaners, and that's going to be like window cleaner. I'm going to put Windex. And Windex has NH3 in it. And we talked about that in our video yesterday. NH3 is ammonia, and that's the active base that's in most of your cleaners. Somewhere right around 12 would be milk of magnesia. Most of y'all are going to say, what? Milk of magnesia? This is antacids like a Tums or Pepto-Bismol, milk of magnesia, any of those. That's going to be it. All right, the next thing that I would like to do is I would like to look at this, how to identify them and what it looks like. So if you're an acid, you're looking at hydrogen ions. If you're a base, you need to be a hydrogen ion acceptor. So we have OHs. So I have a positive and a negative. Well, guys, if these were to bond together and come in contact with each other, it would make an HOH, or H2O. So that is right here talking about the water, where water is going to come from in the neutralization reaction of an acid, which is hydrogen ions, and a base. Now, a lot of times, students don't realize what's going on these ion levels. So I'm going to draw a couple of graphs for you. And the first graph is going to deal with an acid. So if I'm looking at the concentration of hydrogen ions, in order for it to be an acid, it has to have extra hydrogen ions. Well, that doesn't mean that it doesn't have any OH ions. That just means that it has more of the hydrogen ions than it does the OH ions. So because it has these extra hydrogen ions, it's going to be considered an acid. So if I come over here and I look at a graph of a base, it looks very, very similar, just the opposite. It's going to have a lower concentration of your hydrogen ions and a much higher concentration of your hydroxide ions. So therefore, this would be considered basic. Now, what's going to happen if you have a neutral substance? You got it. It will have the same amount of each. So we have the same concentration of hydrogens as we do the OHs. So you have none left over. You have 100% H2O being created. So what have I talked about in today's mini lecture? First of all, the pH scale. The pH scale is used to determine if something is classified as an acid or a base. What does pH stand for? It stands for the negative log of the hydrogen ion concentration. What is concentration? It's the number of moles of my solute divided by the total volume, liters, of my solvent. Then we talked about some common examples and what their pH are. Finally, we went back in and we looked at graphs that allow you to look at the amount of concentration of my hydrogen ions versus the concentration of my OH ions. So I hope that was informative and y'all learned a lot from that one. You have a good day, and I'll see you at the next mini lecture.